addition of Cartesian vectors. Looking at this question here, the question is asking us to determine the resultant force acting on the hook. Visualizing this question here, we can see that two different forces acting on the same point. But also when we look at the question, I can add more information on that question so that I'll make it easy for me to solve the question. For example, looking at this component here coming out of the x-axis, I name it F2y dash. Why did I name it F2y dash? It is parallel to the y-axis. This component here is parallel to the y-axis in there. Therefore, I named it F2y dash. You can name it anything that you like. I named also this component coming out of the z-axis towards us in here. I named it F2a. You can name it again anything that you like. The component going downwards in here, I named it F2z dash since it is parallel to the negative z-axis. Now, all of the information being given on this question right now, we need to interpret it down mathematically. So the first step that we're going to do is to write down what is being given. So what is being given to you in the question? We know that F1 equal to 500 Newton. Associated with it, special triangle 3, 4, 5 or similar triangles. We know that F2 is equal to 800 Newton. Associated with it, theta 1 is equal to 30 degrees. Also theta 1, that's theta 2 equal to 45 degrees. I already associated some names or some letters to these components in there. Therefore, I'm going to say F2 on y dash is equal to F2y, as they both parallel to each other. F2 on the z dash, F2z dash equal to F2z, because again they both parallel to each other. Now looking at what the question is asking us to find. So the question is asking us to find Fr, the resultant force. So solution. In the solution, we know that Fr is going to equal to F1 plus F2. So now we have to solve for F1 and F2. So the first step, solving for F1. In order to solve for F1, we have to construct a free body diagram. The free body diagram for F1, in this case, we have Y, Z, and X. We know that F1 is coming out between the Z and Y. Resolve it into two rectangular components and is being given special triangle 3, 4, 5. Since these are all the information given regarding the F1, and F1 doesn't have an X component in there, therefore we know that F1 is equal to F1 on the X direction plus F2 on the F1 on the Y direction plus F1 on the Z direction. So F1 on the X directions doesn't have anything on the X direction, therefore F1 on the X direction is equal to 0 Newton. What about F1 on the Y direction? In this case, if we have theta in here, in this case we can say cos, and we're trying to find this component F1 on the Y direction, this component, therefore we can say cos theta equal to the adjacent over the hypotenuse. However, in this case we don't have the theta, but we've been given this information here, which is similar triangle. We're looking at the parallel side, which is 4 parallel to the Y, and that's what we are looking to find in there. So to solve for that one, we can say cos, if we had theta, we're going to say cos theta equal to F1y, F1 on the Y direction divided by F1. However, we don't have theta, Therefore, we're going to compensate parallel to the f1y, the side is 4, parallel to f1 here, the side is 5. Now, we are going to say f1 on the y direction, f1 on the y direction equal to f1. Of course, we said f theta, cos theta is not there, but we're going to compensate with 4 over 5. In this case, f1 is 500. In this case, 500. F1 is 500 Newton times 4 over 5. And that equal to 400 Newton. Solving for f1 on the z direction. Again, if we had theta in there, we will be saying sine theta equal to f1 on the z direction over f1, but we don't have sine theta, so we are going to compensate this by 3 over 5. Remember that. Therefore, f1 on the z direction equal f1 times 3 over 5, and that equal to 300 Newton. Now I found all the components for f1. On the x-axis is 0 Newton, on the y-axis is 400 Newton, and on the z-axis is 300 Newton. Now expressing this expressing f1 in Cartesian form. So Cartesian form for f1. So f1 in this case equal to, you can say 0I plus 400J plus 300K, and of course F1, the unit for it, it's Newton. Now we are going to solve for F2. Show my free body diagram in this way. So here I know this component in here is the z-axis, this one in here it's the y-axis, and this one here it is the x-axis. Now F2 is coming downwards in this direction. This is F2, and I know also another component is coming out in this direction here, making 30-degree angle with this one here, this making a right angle with the x-axis, and going down until it meets with this one here. So we know this one here it is 30 degrees, this angle in here it is 45 degrees, we know this is 90, and we know this one we named the F2y dash, this one here F2z dash, and finally this one here we call the F2a, and this is F2. Pretty much these are all of the information given to us in the question. So I will start my solution by saying F2 is equal to F2 on the x-axis plus F2 on the y-axis plus F2 on the z-axis. So solving first thing for F2 on the x-axis, that since we have this component in here, F2 on the x-axis, which is this component in here, okay, and we have this theta in there, therefore we can say cos 30 equal to F2 on the x direction divided by the hypotenuse, which is F2a. In this case F2a, this is the hypotenuse, so adjacent over hypotenuse. Now F2x equal to this one, solving for the F2x, F2 2a times cos 30. However, f2a itself is not being given, so we have to solve for it. We've been given here that's 45 degrees. Therefore, we can say since this is a right angle as well in here, so we can solve for this one, and we can say cos 45 equal to adjacent f2a divided by f2. Therefore, f2a equal to f2 times cos 45. f2 it's 800 Newton, cos 45 0.707, and that should equal to 565.7 Newton. Compensate or substitute this value back into the f2x. Therefore, f2 on the x direction equal to f2a, which is 565.7 Newton, multiplied by cos 30 times cos 30 degrees, and this one should equal to 489.9 Newton. We found the x component of f2. Now we are going to work for solving for f2 on the y direction. Now f2 on the y direction, we know f2 on the y direction equal to f2y dash. So f2 on the y direction is equal to f2 y dash. So let's solve for f2 y dash. Now if we say sine 30 equal to f2 y dash divided by f2a. Solving for f2 y dash equal to f2a times sine 30. f2a we already found it to be 565.7 Newton times sine 30, that's 0.5, and that should equal to 282.9 Newton. f2y equal to f2y dash equal to 282.9 Newton. We found the second component of the force. Finally, we working for f2 on the z direction. So simply we know that f2 on the z direction is equal to f2z dash. Now solving for f2z dash, so we know that sine 45, if we say sine 45 equal to f2z dash divided by f2. Now solving for f2, z dash is equal to f2 sine 45 degrees. f2 itself is 800 Newton, sine 45 0.707, and that all should equal to I think it's 400 Newton. But f2 on the z dash, it is negative itself because it's on the negative direction. Therefore, f2 z dash is equal to negative 400 Newton. Now we found all the components of the f2, expressing it in the Cartesian form. Therefore, Cartesian form for f2. Cartesian form for the f2, we know that f2 equal to the x component. We found it to be the x component in here, f2 on the x directions, 489.9 Newton I 489.9i plus the y component 282.9j plus the z component, it's a negative 400k, and of course it is in Newton. And now you can add f1 plus f2, therefore now you can say f1 plus f2, the Cartesian form. We know that f1 on the x direction had 0 I component, therefore 0 I plus 489.9i plus the j component. For the f1 it was 400j plus 282.9j. The k component, it was plus 300k for f1 plus the minus 400k. So if you collect here all like terms, this is how you express it in your on the right terms, on the Cartesian form. So you can add this or simplify it further, one more step basically. So this one here will result into 489.9i plus 682.9j minus 100k, and of course it's Newton. And this is how you solve for FR. Thank you for watching, guys. We'll see you in the next video for more practical problems like this.